Good day everyone. Classification of sums based on properties of determinants. This video brought to you by mastermax.com. If you want to learn more, visit our blog. The blog address is given here. If you take the chapter on determinants, many students will say only sums based on properties is difficult to solve. Actually, they don't know which property to use and start the sum and get the factors given on the right hand side or how to prove that sum. So, let us now classify the sums into some categories and to analyze which property to use in which type of sums. Then it will be easy for you to understand and then proceed and solve the sums based on properties. Shall we move to the sums now? Let us have a quick glance of the properties of determinants before we proceed to the example sums. First property, value of a determinant is unchanged if you interchange the rows into columns and the columns to rows. That is, the value of a determinant and the values of the determinant transposed will be same. Okay. Second one, if you interchange any two rows or any two columns, the sign of the value of the determinant will change. Third one, if any two rows or columns are identical or they may be proportional, then the value of the determinant is equal to 0. Fourth one, if you multiply the elements of any row or column by a constant k, then the value of the determinant is also multiplied by the same constant k. The fifth one is, if the elements of a row or some elements of a row or column is expressed as the sum of two or more terms, then you can split the determinant also into two or more determinants. The sixth one, which is a very important property and often used property, okay. To each element of a row or column, you can add multiples of the corresponding elements of other row or column. The value of the determinant remains the same. So, you should be first thorough with all these 6 properties, then only you can decide, you can identify which property to use and solve the sum, okay. Before starting the sum, let me tell you one thing. In any prove that sum in a determinant, you cannot straight away expand it. You should try to get 2 zeros in a particular row or in a column, then expand by that row or that column. This is the common concept which you should do, okay. Now, let me read the sum first. Prove that first row 1, 1, 1, second row A, B, C, third row A cube, B cube, C cube is equal to A minus B into B minus C into C minus A into A plus B plus C. This type of sum I put under the category type 1, that is, you will have 1 in either a row or in a column, that is, all the 3 elements will be 1 in a row or in a column. This is the easiest and the basic type we can call. So, now in the given sum, you have a 1, 1, 1 in the first row, that is R1. Now, I will try to bring 2 zeros using some column operation, okay. So, now if I do C1 gives C1 minus C2 and C2 gives C2 minus C3, automatically I will be getting 2 zeros in my R1 in 2 places, okay. So, what does it mean? From each C1 element, you should subtract the corresponding C2 element. Similarly, from each C2 element, you have to subtract the corresponding C3 element. The C3 element will not change because we are not doing any operation to change it, okay. So, now your LHS will become, after you perform these 2 operations, it will become 0, 0, 1 first row, A minus B, B minus C, C second row, A cube minus B cube minus C cube is the third row. Now, I have got 2 zeros, but I am not going to expand now. Always try to take any common factor out and make your determinant as simple as possible. So, now I am taking A minus B common from C1 and B minus C common from C2. Okay. So, do you understand up to these steps now? Before taking A minus B common from C1 and B minus C common from C2, you have A cube minus B cube and B cube minus C cube as two elements in your R3. You should know the formula for taking A minus B and B minus C out. So, A cube minus B cube is equal to A minus B into A square plus AB plus B square. Similarly, B cube minus C cube is equal to B minus C into B square plus BC plus C square. Okay. So, now you are taking it out and the resulting determinant after taking the common factors out is 0, 0, 1, 1, 1, C, A square plus AB plus B square, B square plus BC plus C square, C cube, right? You are going to expand it by R1 because that only contains two zeros. Now, first write whatever be the common factors out. So, you will write A minus B into B minus C. Then start expanding the determinant which you know already. So, you are getting within the bracket B square plus BC plus C square minus A square plus AB plus B square. If you expand, the two B square will get cut. You can factorize C square minus A square as C plus A into C minus A. Take C minus A common from the two terms. So, you are getting the result, that is your RHS, which is A minus B into B minus C into C minus A into A plus B plus C. Okay. Are you clear about this sum? Now, you try the sum I have given for you to solve exactly in the similar way of this sum. So, if you do that, this type you will be very clear. Then we will move on to the next type. Let me read out the next sum. Prove that x plus y plus 2z x y, z y plus z plus 2x y, z x z plus x plus 2y is equal to 2 into x plus y plus z the whole cube. Now, this type of sums I call type 2 because if you add all the rows or in some sums if you add all the columns, then you will be able to get one common factor which is on the RHS out and you will be getting a 1, 1, 1. So, it will become type 1. So, this let us call it as type 2. Now, if you look at this sum, if you analyze it carefully, if you add C1 plus C2 plus C3, what do you get? You will get everywhere 2x plus 2y plus 2z in your C1. So, you can take 2 into x plus y plus z common in C1, so that you will be getting a 1, 1, 1 in your C1. So, whatever you get in your C2 and C3, once you get a 1, 1, 1 in C1, this sum becomes type 1. So, now you have to get two zeros in your C1 and you have to expand it by C1. To get zeros in the column, you have to perform row operation, that is R1 gives R1 minus R2 and R2 gives R2 minus R3. Okay. If you do that, you will be getting two zeros. If there are any other common factors, take them out and expand. Can you make a try yourself? Surely you can. Okay. Thank you for watching the video. To understand and learn more concepts, visit our blog. The blog address is given here. Subscribe to our channel to get notifications of further videos. Any comment, any queries, post it in the comment section. Thank you again.